Welcome to today's video, where we dive into one of the most exciting breakthroughs in energy science: fusion energy. Imagine a power source so strong it could fuel the stars, yet clean enough to power our planet without pollution. Fusion energy promises endless, sustainable power for the future. In this video, we'll explore how it works, its challenges, and why it's called the ultimate energy solution for humanity. Stay tuned, and don't forget to subscribe for more future tech insights. Number 5. Limitless fuel supply. Fusion energy stands out because its fuel, hydrogen isotopes like deuterium and tritium, is extremely abundant. Deuterium can be extracted from seawater, and tritium can be produced from lithium, which is also widely available. This means humanity would have access to energy for millions of years without worrying about depletion. Unlike fossil fuels that depend on limited underground reserves or geopolitical factors, fusion's raw materials exist naturally and evenly distributed across the globe. A single liter of seawater contains enough deuterium to generate the same energy as hundreds of liters of oil. This abundance could eliminate global energy crises, reduce energy costs, and ensure stable power for all nations. Moreover, because fusion fuel is light and easy to transport, it offers flexibility in building power plants worldwide, even in remote areas. With such an inexhaustible energy source, future generations would no longer face energy scarcity or rely on polluting sources like coal or oil. This shift toward an abundant, clean, and sustainable fuel supply could fundamentally reshape economies, empower developing nations, and create a truly global and balanced energy future driven by fusion power. Number 4. Clean and green energy. Fusion energy is one of the cleanest power sources known to science. Unlike fossil fuels that release harmful carbon dioxide and other greenhouse gases, fusion emits none. Its process involves fusing light atomic nuclei, like hydrogen, into heavier ones, releasing immense energy without producing long-term radioactive waste. Unlike nuclear fission reactors, which generate hazardous waste requiring thousands of years of storage, fusion's byproducts are minimal and short-lived. This makes it far safer for both people and the environment. The absence of greenhouse gas emissions means fusion can directly fight climate change and air pollution, which currently cause millions of premature deaths each year. Fusion plants also require far less land compared to solar or wind farms, reducing environmental disruption. Because it's clean, it can be placed near urban areas without risk of contamination. Additionally, fusion does not consume large amounts of water or emit harmful radiation into the atmosphere. Its eco-friendly profile positions it as the ultimate green energy solution, capable of providing sustainable power to billions without destroying the planet's ecosystems. Fusion represents a truly carbon-free and pollution-free pathway to achieving global environmental balance and long-term climate stability. Number 3. Extreme power output. Fusion energy produces a staggering amount of power from minimal fuel. When hydrogen nuclei fuse, they release energy millions of times greater than chemical reactions like burning coal or oil. For example, 1 kilogram of fusion fuel can yield the same energy as nearly 10 million kilograms of fossil fuel. This incredible efficiency could completely transform global energy systems. It means smaller quantities of fuel can power entire cities for long periods, reducing transportation, storage, and extraction costs. Fusion's high energy density also allows for compact reactors, unlike large fossil fuel plants that require vast infrastructure. This efficiency can make electricity cheaper and more accessible worldwide. Additionally, fusion's immense power generation could support industries requiring heavy energy use, such as manufacturing, data centers, and space exploration, without harming the environment. The combination of immense output and minimal waste makes fusion the most powerful and practical energy source ever envisioned. If successfully commercialized, it could easily meet humanity's growing electricity demand, drive industrial progress, and sustain economic growth on a scale never before possible, all while keeping the planet clean and sustainable for future generations. Number 2. Safe by design. Fusion is inherently safe because its reactions cannot run out of control. Unlike fission reactors, which can experience dangerous meltdowns, fusion requires extremely precise conditions, high temperature and pressure, to sustain itself. If any imbalance occurs, the reaction instantly stops on its own, eliminating the risk of catastrophic failure. This natural safety feature makes fusion far more secure than current nuclear technologies. Additionally, the materials used in fusion do not create long-lived radioactive waste, nor do they pose risks of weaponization or nuclear proliferation. The reactor walls may become slightly activated after long operation, but this radiation fades within decades, not millennia. Furthermore, fusion reactors cannot explode because they lack the chain reactions that drive fission-based disasters like Chernobyl or Fukushima. The fuel used, mainly hydrogen isotopes, is not highly radioactive, making it safe to handle and transport. Fusion's design ensures the safety of nearby populations and workers, while strict engineering standards and magnetic confinement systems further enhance operational stability. With these safety measures, fusion power promises to deliver reliable energy without the constant fear of accidents or environmental hazards associated with traditional nuclear plants. Number 1. The future is near. The dream of harnessing fusion energy is closer than ever before. For decades, scientists viewed it as an energy source of the distant future, but recent technological breakthroughs have changed everything. Projects like ITER in France and private ventures, such as Commonwealth Fusion Systems and Helion Energy, are making real progress toward achieving net energy gain, the point where a fusion reactor produces more energy than it consumes. Advanced computer modeling, stronger superconducting magnets, and better plasma control have accelerated development, turning fusion from theory into engineering reality. Some experimental reactors have already sustained stable plasma for longer durations, proving that controlled fusion is achievable. Once fully developed, fusion could revolutionize the world's power systems by offering unlimited, clean, and affordable electricity. It would end dependence on fossil fuels, stabilize global energy markets, and provide sustainable power for generations. Nations investing in fusion today are preparing to lead the next industrial and energy revolution. The world is on the brink of witnessing history as the power of the stars becomes humanity's ultimate energy source, ushering in a new era of prosperity, innovation, and environmental harmony. Thanks for watching this deep dive into the world of fusion energy, the limitless power source shaping our tomorrow. The future of clean and sustainable energy is closer than we think, and fusion might just lead the way. Stay curious, stay inspired, and make sure to subscribe for more.